Hey guys, so in last session we understand about the different modes of the AP that we understand. What is autonomous AP? What is the lightweight access point that is going to connect the WLC? How the cap web tunnel is going to be created, okay? And how the communication is going to happen from the any AP to the any WLC that we understand and why it is going to be required because in autonomous AP we do not require any kind of the WLC, so cap web tunnel is not going to be required. But when we have the lightweight AP that we can see here, right? So this is going to require the cap web tunnel, and we know what is the cap web tunnel. This is a secure tunnel which is going to be created between the WLC and the AP, especially for the lightweight AP, and this is going to get all the control and data connection. It's totally depend how you are going to deploy the this WLC and the AP modes of the deployments. Then in some scenario only the control connection is going to be shared to WLC. Control means the brain related information is going to be shared, and some of the scenario it's also going for data and communication also going through via the WLC. So it's totally depending how the switching mode is going to be used, that we discuss in the upcoming slides. But yes, this is how cap app is going to be required, and this cap app is the very important, and this is going to be very secure because that control and provisioning of the wireless access point, that is known as the cap app tunnel. So now let's move to the WLC. Before we start understanding about the function of the WLC, we have to understand how the WLC is going to be look like in the production environment. Means whenever your company want to build any WLC, then how this communication is going to look like. So in our scenario, how the communication is going to be, let's suppose we have the office, branch location office. So my WLC could be the branch office location itself, or it might be going to be situated in the somewhere in data center. So let me use some different color. So let's suppose this is my data center. So data center could be have the WLC. This WLC could be here. So both of the deployment is going to be used. Means in every branch location, right? If I have the multiple branch location, if I want to deploy the WLC every branch location, that is going to be huge cost for me because you have to purchase the hardware, and based on that hardware you just have to deploy the WLC, and then your different AP is going to connect to WLC via the switches, right? So you can see this is the how it is a different AP is going to be happen, and then this is the switch, and based on the switch this is going to be connected. So basically all AP need to be join the WLC, especially when you have the lightweight APs. And after joining this is a switch, and this is the WLC, and these are the APs. These are the all APs. This is a switch, and this is a WLC. So in this scenario, only problem is going to happen. You have to purchase more WLC, and all APs are going to build the cap-up tunnel over the LAN infrastructure, right? But let's just suppose I want to minimize the cost. Then how my design is going to look like. So this is my data center. This is my DC location. DC location have the again the switch might be you have the here switch is there. You have the WAN router also, right? This is how, and this location also you have the WAN router. This location also we have the WAN router. So if I don't want to use the WLC in my branch location, then what is going to be happen? My all branch location are going to connect with the, let's suppose I have the MPLS circuit, or let me put it more generic. Instead of the MPLS, I'll just provide the ISP. These routers are going to connect to the ISP, and this is how it is going to connect to the data center. So my these APs are going to build again a cap-up tunnel from my branch location. This is my WLC, okay? So my branch location AP is going to build the cap-up tunnel to the this WLC over the WAN. So my WAN is going to be act as a transit to just form the cap web tunnels. So for any kind of the control connection, my AP always going to reach to WLC over the WAN, and then they are going to provide the Wi-Fi services. This is one architecture, right? If you have the local WLC, then you can see this is my AP. This AP might be connected to the access layer switch. We know what is distribution layer switch, what is the core layer switch, or might be we have the single layer of the or might be the collapse core where we don't require the distribution layer. We just have the core layer and the access layer, or might be distribution layer or core layer going to be collapsed together. So that scenario is also available. So in that case, my CAPWAP tunnel is going to be formed over the switching environment to the WLC. So this is how it is going to be happen. Okay. So this CAPWAP tunnel is going to be, so this is locally to the site, local to the site. So WLC location can be in remote location, can be in the branch location. It totally depends how your company is going to be design your wireless network. So some of the scenario you are going to find, if this is a big site, this might be WLC is going to be situated at the same site location. If my sites are very small, so I'm just going to use a centralized WLC which are hosted in data center environment. Okay. So in most of the scenario nowadays, we have in the cloud WLC, cloud based, right? Cloud based WLC. Meraki solution, you always going to find the cloud based, no site level WLC is available. Even for the any 9800 WLC deployment, where we are talking about the very latest Wi-Fi solution, that is also cloud based WLC. So majority of the scenario, you're probably going to find WLC always going to be centralized location, not a localized location, and this is how it is going to serve the network. So now if I talk about the WLC functionality, what is WLC? Okay, and what the key functionality of WLC, right? So WLC, if I just abbreviate, that is a wireless controller, right? WLC is a wireless LAN controller. That's a more specific answer can be abbreviated. So let me write here. WLC stand for the wireless local area network controller. So if you see, this is the controller. So how it can be defined? So it's a network device used in the wireless networking, right? Deployment of this WLC is to just manage and control the multiple APs. This is the primary, means if my office's branch location have the multiple APs and I want to control them, manage them, then I need a WLC. And these AP, if they are working in the lightweight access point, right? So this is basically a centralized base functionality, WLC centralized based functionality, and this is going to be managed by setting in the dashboard of WLC. Let me show you how WLC dashboard is going to look like. So at least you will get some idea. So let me go there. Cisco WLC dashboard. So if you see here, go in the images. So let me show you the legacy one. You can see this is the WLC. So you just have to log in this WLC, right? Let me show you the picture. So this is the image of the WLC, and once you go in WLC, see this is situated somewhere, the AP is situated, this is your WLC connected to the switches, and client are some serving there. This is the power, you can see here different option they have explained in this article. And once you go and log in this WLC, so it is going to give them kind of dashboard, which probably will see in the later stage. Let me show you. Yeah, so see, this is a WLC dashboard. In this WLC dashboard, you can see, you can get all the AP information. You can configure the multiple bands, the frequency band which we discussed earlier, 802.11a, b .11b/z, a, b, g. So different band we have a, and what are the frequency range that they have configured, right? Traffic type. So this all are there, and we can see the dashboard and the RF and all, monitoring how many AP are connected and all. So this basically dashboard is going to be open once your WLC is going to be reachable in the network, and you can log in it. And after logging this WLC, you can configure, you can manage, you can create the SSIDs, you can configure the AP, you can just manage the coverage area. So a lot of things you can provide redundancy and other application detail, what is like running inside of this wireless communication, how many clients are connected, how many access points are there, right? So everything you are going to get from this. So in short summary, WLC is just for the wireless LAN controller, which is just going to manage the multiple APs, which is going to be centralized location. It might be the branch location, it might be data center location, it totally depend on your deployment. So this WLC is going to create a dynamic channel where the RF frequency are going to be created, right? Means that WLC automatically choose the radio frequency channel by use how AP is going to be connected, and how they are going to provide the coverage. Like transmission power also going to be optimized. Means let's say suppose my AP let's suppose this is my AP. What is transmission power? So this is my access point. Just think about. So if I give the low power, so probably the coverage is going to be low, right? So if a power is low from this AP, so coverage is going to be low. But if I increase the power, might be the coverage is going to be very high. So this also going to be part transmission power. The WLC can automatically set the transmit power of the each AP based on the coverage area needed. Means the more power you are going to give, the more area is going to be covered, right? If low power, it is going to low area. But while managing the power, it's very important also we have to take care interference. Let's suppose I'm giving a too much power and there is a neighboring AP, this is also having a too much power, the signal is going to be interference in that case, so you having the bad quality of network. So this also need to be taken care. Self-healing wireless coverage means by the help of WLC, what is the self-healing wireless coverage? Let's suppose if AP radio die means I have this area and this area I have two APs. This is one AP and this is another AP, right? This AP is covering this much area. Just think this area is covering and this AP is covering that much area. This area is covering by this AP. For some reason, this AP is going to dead, right? So what is self-healing wireless coverage? So automatically WLC will understand and it is going to be increase the power of this AP so that this area is also going to be covered, and user who is sitting in this area, they are also going to get the high quality of signals and they are going to access the internet on the intranet of the company, right? Client can also roam, like this also going to provide the flexibility. Roaming means what? Let's suppose I'm in the my office, this office having the multiple AP, right? Multiple AP having the multiple coverage, right? But each AP having different coverage. So let's suppose I have the some kind of the laptop, I am moving from this location to this location, so I'll move seamlessly, my connection is not going to be terminated, my connection is not going to be disconnected. So this is the roaming means I can roam from anywhere without any disruption. So this also having this capability of the WLC functionality and the wireless system functionality, where the connection is going to be roam for the any active client without any kind of disruption, right? It is also going to do the load balancing based on the more and less AP are going to be connected and position and having the same the coverage in the same geographic area. The WLC can associate the client with the list use AP and distribute the client load across the access point. Means if I have the more clients in the same area and I have the available AP which having the low load, then automatically the load is going to be shifted and my client is going to be moved from the one AP to another AP and they're never going to understand what is happening. So this WLC in background, they are going to do a lot of things in the automatically, right? RF monitoring, let's suppose the WLC can manage each of the AP so that it scan the channel to monitor the RF uses. By listening to the WLC channels, WLC can remotely gather the information about the RF interference, noise signal from the neighbor's AP and signal from the rogue AP. What is a rogue AP, right? And how the signal interference is going to be so say noise, signal interference, RF interference, rogue AP, these are the bad things. Bad things means they are going to create a problem for you. So WLC having the capability, any kind of the problem is going to happen in my network, so they are going to detect those problem and automatically they are going to put some kind of the restriction for those problems, so that problem is not going to disturb your services. We'll discuss about what is a rogue AP and how the interference and noise is going to be created. But yes, if this RF means radio frequency is not going to monitor, so there might be some issues is going to be happen, you having the bad quality, you might be not able to access the internet and all. So this WLC is going to help you to just protect this kind of the issue, right? Additionally, security management, you can say security management, it is showing that WLC can authenticate the clients. Means if you are joining the any kind of WLC, means not WLC AP, for the accessing the any wireless media, so how authentication is going to be happen? So authentication is going to be happen based on the different authentication security management we have in the our wireless method. So any clients who wanted to access the wireless system or wirelessly they want to connect the internet or intranet, that client must be authenticated, and that required the wireless client obtain the IP address from the trusted DSCP. Means they need IP address. So before authenticating, they cannot get the IP address, and if you are not fail to authenticate, they cannot access the internet like what internet or intranet, whatever we have. So this is how it is going to happen. And also they act as the intrusion prevention system, like protection system, wireless intrusion protection system. Leveraging the central location, WLC can monitor the client data, detect the prevention, like the potential malicious activity. Means likewise the firewall, its data is going to be protected if any kind of the malicious content, malicious things is going to be happen from the network. So these are the key functionality of the WLC. Like we have the automatic channel assignment, we have the power optimization, we have in a self-healing problem, it is going to be solved. Any roaming related issue is going to be addressed by WLC. Client load balancing is going to be happen within the APs. RF monitoring, that's why we can avoid any kind of the interference noise and any kind of the ROG AP detection. Security management and IPS management also we have, right? So at least we understand this concept, what is the WLC role and how it is going to be positioned, right? So moving next, and we just have to understand a little bit more about it. So you can see this is my cloud-based WLC. This is my location, like the same site WLC, but if I want to locate in a different location, cloud-based, that can be also like deployment is going to be happen, especially the Meraki deployment. And embedded WLC, even for my site branch location within the switch, I just want to connect access layer itself. So that can be also possible. So design can be happen in a multiple way, within the site, within the branch, within the region, within the one network where one subnet I can deploy. This WLC can be placed, right? You can see this is like the lightweight APs, and WLC is just express WLC. You want to do the any kind of the local switching in like the control connection locally, then can be possible. And this is how we have the summary of the deployment models. So unified, always the centralized WLC. Cloud, that is a data center. Embedded, that is a access layer deployment is going to have. Mobility, that is going to be a branch location, a small campus. You can see the location also they have given that. So if you have the very big location, that unified deployment model, you just have to use centralized, right? Client supported 64,000. Large enterprise means your company is very large. Cloud, private cloud, 32,000 client can be supported, right? AP you can support it 3,000. Embedded, that is for the small site and small campus, 200 AP, 4,000 client. And mobility, very small site, like I want to have just 100 AP, right? And that I want to use that 200 client supported branch location, that can be done. Autonomous, basically there is no WLC, there is no like every WLC, there is no WLC, every AP is going to act as a standalone, right? And they are going to just serve our all the network. So I hope you guys understand. Now let's understand about different AP modes, right? Cisco AP mode. So this AP mode having the different local mode we have, monitor mode have, flex connect mode have, sniper mode we have, and in addition of that also a few modes also. So let's understand, like we have this rogue detector, which we just discussed in previous slide, and we have the bridge, we have the flex bridge, AC connect. So what is this mode? One by one we just have to understand. So let's suppose I purchase the AP, and if I like if I purchase the AP, I have to decide the mode of the AP. Means this AP I purchased from Cisco, so this AP must have some mode, right? So if I put a local mode, then the behavior of AP is going to be something different. If I put in the monitor mode, then it is going to work differently. Just you can think in this way. uh, you have the public transport, right? Just you can think public transport, and in this public transport we have the category is the bus. Bus is the one object, bus is one type of the transport. This bus can be used for the open public, means open public means any public can travel on it. This bus can be used for the any army personals, so army can be travel on this bus. This bus can be open for the any police one, so police can only travel on it. So bus is going to be same, but use case of bus is going to be different, right? If bus is going to be used for the school purpose, so that school kids are going to be travel on it. So this is the one type of the public transport, but the use case of this public transport is going to be totally different. Similarly, AP is just one device, but how and which scenario it is going to use for what purpose, that is going to be understand. So if I am just going to discuss about the local mode, what is the local mode of the AP, right? So in the local mode of the AP, in this local mode, by default, lightweight mode that offer one or more function, right? That is a basis and subsystem on the specific channel during the times that it is not transmitting. AP will scan other channel to measure the level of the noise, measure the interface, discover the rogue access, and match the against intrusion detection system IDS event also. So whenever you're just going to purchase, by default, all mode of the AP is going to be put in the local mode by default, right? And this is something where you have the like the communication is going to happen. And how this is going to be happen, let me just show you something very important so you guys can understand. Just give me 1 second. So basically what I'm talking, like this local mode, basically it's talking about a default lightweight mode. So this is when you have in the not autonomous system AP, we are talking about the lightweight AP, which is required to WLC. Then it is going to offer the BSS, right? BSS is just like just it is going to support the SSIDs where the specific channel is going to be broadcast, and you are going to connect the WLC via the AP. Means AP is going to connect WLC and client is going to connect to the APs, right? But let's suppose there is no any clients available. There is no any clients available to connect the AP. Then what is going to be happen? If there is no client, let's suppose these clients are connected on this AP. So then definitely it is going to serve. This is going to be served. This is the PC connected to that. But let's suppose all client has been gone. So this AP still keep radiating the signals. This AP still keep sending the signals. In this scenario, what is going to happen? So there is no client, but still this local mode is going to do something. What it is going to do something? The first thing, it is going to measure the noise. Means if any noise is going to be happen, it is going to measure. The second thing, any interference is going to be happen, that is also going to be measure. Interference is also going to measure. Any rogue detector. So what is the rogue AP? Means any bad device who is trying to connect your network to just hack your network, like just trying to manipulate your data, like something bad AP is going to be connected. So that also going to be detected by the local mode. So rogue AP devices are going to be detected. In addition of that, IDS event, like any kind of the intrusion preventions detection is going to be happen. So that going to deduct, and based on that you can take an action. Alert is going to be generated. So local mode is like very useful mode. It is going to serve your signals to get the connectivity. In addition of that, also you are going to get the very good signals in terms of the coverage, and also they are going to measure the noise. If any noise is going to happen, that going to report, and it is going to apply the algorithm to how to minimize the noise. Interference is also going to measure, and then it is going to be also detect the rogue AP, and the IDS event is also going to be matched and checked. So this is the key function of the local AP, right? Now if the same AP I am going to deploy in the monitor mode, then what is going to happen? So this monitor mode, basically it is not going to give the signals. Means in this monitor mode, actual clients, means if you have the laptop, you want to connect the internet or internet of the company, this is not going to be happen. So AP monitor mode doesn't transmit at all. Means there is no transmission of the SSID, BSSID, whatever we have. It all like having the functionality to just similar to the local mode. It just check the IDS events. Like IDS is intrusion detection system. So basically any malicious things is going to be happen, that is going to be detected. Any rogue AP is going to be connected, that is going to be detected. Any positioning, like determine the positioning of the wireless station, right? So anything which is going to be bad in terms of the positioning of the any APs, that is also going to be monitored, right? So in this case, you cannot broadcast the SSID, means you cannot connect the network, but yes, it is going to help to detect the any rogue AP connectivity, any IDS, any kind of the wrong positioning. So the question is, why should I use the local? Why should I the monitor? So that's why monitor and local having the key difference. Monitor can only do the monitoring, which local can also do. But local also do the SSID broadcast, means you can connect the network. That's why every time when you just buy the AP, by default your mode is going to be happen the local mode only, not the monitoring mode. You just have to change. Monitoring means you cannot broadcast any kind of the signals to the clients, any user, but local you can do, plus you also do the monitoring as well. Now the third, we have the flags connect mode, right? This flags connect mode is like quite popular, right? It is also going to be very kind of the useful case, right? So it's a possible to connect the local mode AP at the remote branch, or might be just you have to connect in the headquarter WLC. This works, but it is not a good idea. Means flags connect mode, you want to connect the any local mode AP at the remote branch to connect the WLC, which is in the headquarter or might be data center location. This work, but this is not a good idea. First, what is the problem is going to happen? First, all the APs which have on the branch location, they have to send all the communication from the CAPAP tunnel. Means I have the WLC in the central location, I have the APJ here, so my all the data must be processed, control connection plus data connection via the CAPAP tunnel, right? So the data, client data should be traveled through the CAPAP tunnel to the WLC via the WAN link. Means if you have the remote WLC, you just have the WAN links. Secondly, when the WAN link goes down, your wireless network at the branch site is offline too, right? So this is something not a good idea. So if you are using the local mode and your WLC is there, all the connection, data, control connection, everything is going to there. But let's suppose your WAN is going to be down, then you can lose the all kind of the communication. So let me make it more clear. So let's suppose I have this branch, look, this is my data center, right? Let me write it here. What I'm trying to say there, data center, and this is my branch location. Okay, this branch location have this router, this is router, and over this we have the WAN, disconnected, disconnected. My WLC is here, right? I have the AP here. This AP connected to the switch, right? This is switch, this is the router, this is router, this WLC is also connected with the switch. So this AP, let's suppose I deployed the like local mode and my WLC in the data center. So my all like the CAPAP tunnel is going to build over the WAN. So my all data and control connection is going to travel over the CAPAP tunnel to WLC. This is my CAPAP tunnel. So everything is going to process via the WLC. But if my WAN is going to be down, I can lose the all client connectivity because I am not going to any instruction. But if I connect this deployment as a flex connect mode, then what is going to happen? In the flex connect mode, what is going to happen? Still you are going to get the like control information from the WLC, but your client traffic, let's suppose I have one client connected here and another client connected here with a different APs, right? So if they are communicating and some reason I lost the connection for the CAPAP tunnel, but still the data is going to be transmitted locally within the VLANs, within the SSID, and where the CAPAP tunnel is going to be down. So still this is the FlexNet. Since FlexNet mode, your central processing is going to happen, but once your central processing is going to done, your instruction is there and your two devices talking, then data communication is never going to WLC. The data is always going to be happen within the site location. So local switching in flex mode, we just have the local switching. Means any client who want to communicate, they just are going to talk to locally, but you are having a central brain instruction for the any kind of the authentication, any kind of control information. That's why they are talking about NAP at the remote site can locally switch the traffic between the SSID and the VLAN if the CAPAP tunnel to WLC is down. And if the configure to do so, for any region like flex client mode, you are doing that, then still you have the privilege, your captive tunnel is down, but still you can do the local switching. But in the local mode, you cannot do that, right? So this is how it is, the local mode and the flex connect mode deployment having a key difference. Probably you're going to ask in the interview, right? Now you have the sniper mode. Sniper mode, like you just have to do the packet capture. Like AP detect its radio receiving the 802.11 radio traffic from the other source, much like the sniper packet capture device. The capture traffic then forwarded to PC running the any kind of packet analyzer, like the most popular is a Viasat. So it just, you want to capture the packet and you want to just do the analysis, then you can deploy the same AP as a sniper. Means the AP is not going to radiate any kind of a signal, it's just going to act as the packet capture. This is how it is going to happen. This is sniper mode, right? So sniper mode is also going to be useful for some case. Now we have the rogue detector mode, right? So rogue detector mode are like just to make AP device the full time just do one function. You can see in this scenario, local mode also we can do the rogue detection, right? Means rogue device detection. Monitor also can do that, but they having the other responsibility also. But I want to just make my one of the AP to just work as a rogue detector. So an AP is going to be dedicated itself to detecting the rogue devices by correlating MAC address heard on the wired network with those heard over the air. Rogue devices are those that appears on the both network. Means something bad devices, right? Which actually want to connect your network, which are not allowed to connect. So rogue detector is something is going to help to detect those devices. That is my bad devices, and this cannot be broadcast there like in network information and by using the MAC address. And if anything is going to happen, that is going to be stopped by the rogue detector. Basically, it is going to detect, not stop, and based on that, you can take an action. So this is going to be rogue detector. This is a special mode, we can use that. Now we have the bridge mode. So bridge mode, I explained that bridge modes like if you have the point-to-point connectivity, probably we have somewhere in the diagram. Let me show you bridge mode. Uh, we have done the discussion. Let me show you bridge mode WLAP Cisco. So we having a two branches. You can see here. These are two branches. Uh, Basically, two buildings can be there, and you want to just broadcast a signal over the air, right? From one AP to another AP. So that is going to act as a bridge mode. So that's why they're talking about the bridge mode here. So bridge mode and AP become the dedicated bridge point to point or point to multi-point between two networks. Two AP bridge mode can be used to link two locations separated by distance. Means there is two buildings and I want to connect them through the wireless. So I can deploy one AP here, one AP here. It is going to broadcast the signals from here. It is going to receive from here. It is going to receive. That is going to act as a bridge mode. It can be point to point. If I have the multiple building, then I can use a third AP and they are going to again do the communication by this way. This is going to connect this. This is going to connect this. So this is how the multi-point is going to be happen. So that's why they are talking about the AP become the dedicated bridge point to point or point to multi-point when two sides are not need to be communicated to different location, separate distance need to be communicated. Multiple AP in the bridge mode can be form an indoor and outdoor mass network, right? So this is how the bridge mode is going to be happen. And we have the flax bridge mode. Flax bridge mode, like the if we are just going to use the operation to enable the mass, like full mass connectivity, we want to do that, then it is going to be use the flax bridge mode. So let me show you the flax bridge mode so you guys can understand clearly what does mean. So let me go here, flax bridge mode. I have some diagram. So local mass. So there's a full mass network. They want to communicate Cisco AP flax bridge mode. Let me see. So you can see these are the buildings they connected. I have some diagrams where we can have the multiple network in the same campus and they just wanted to communicate right in different location, then it is going to be flags bridge mode. Just give me 1 second, guys. Just hold on. So actually the flags and bridge mode, so flags we already know, flags connect mode we already know. Flags means like we have the central control connections but local switching, right? But if I just want to use the bridge mode, my connectivity toward the WLC for the any control plus data, both are going to be on the WLC, right? So if I deploy any bridge mode deployment, so you can just understand in this way. So let me go there. So you can see here. So you just think about this diagram. So if this any client want to communicate, this client want to communicate this client. So any control connection, any kind of the data connection, both are going to travel to the WLC via the cap web, right? But if I am going to use the flags connect, means that only control connection is going to, like controller data connection is going to be locally, right? If I deploy in the bridge mode, again my control data both are going to WLC. But if I use the flags plus bridge, then what is going to be happen? Flags plus bridge is going to give the flexibility where my still the local switching is going to be in place, but my like the bridge also going to maintain, and control is going to be control processing and central processing to WLC. So flags bridge means I have the local switching and the central processing for the any control connection. AC connect mode is something last but not least. AC connect is like the this is going to be not used in the production, to be honest. Why it is not going to be used in the production? Because AC connect mode enables access point to dictate connection to the Cisco clean air technology to the spectrum analysis. So basically more and less it is going to be used for the just to analyze the spectrum, means the radio frequency, right? So that's why they're talking about the AP dictates its radio to the spectrum analysis on the all wireless network or channels. You can remotely connect PC running on the software such as the MetaGig channel analyzer or Cisco Spectrum Expert to all the AP to collect and analyze the spectrum analysis data to discover the source of the interference. So basically it's like the high level technique where you can just analyze the spectrum, radio frequency, channels. Is there any kind of the issue, like we having any kind of the noise, we having any kind of the interference, and those are going to be basically protected. So this is how AC connector is going to be come in a picture. Okay, so I hope this is going to be helpful for you all, like the different mode of the AP. Now we are going to discuss about few more topics about the WLC architecture and design, and then we'll conclude this session. So thank you so much for watching. Let's connect in the next session of this WLC.